Good morning, everybody. I am going to go over this question right. There are too many of these open. Sorry. Right here, about a radio transmitter that we are getting. We're within the signal within a certain distance. We want to know how many miles that is, and we are given quite a bit of information on it. So I'm going to break up all the pieces of it. So this first part here, the radio transmitter broadcasts in a 54-mile radius. So that means that if we had a circle, let's just make it about the origin to make it easy, the 54-mile radius would look like that. Right? So I'm going to zoom out just so we could see that piece of it. And I'll go just a little bit further back just to make sure we can kind of see where things go. Okay. Now on the next part here, we are driving from a city that's 66 miles north. So if we were 66 miles north of the radio tower, that tower is right here at the origin. Well, then that means we would be right there, right? So we're starting on this one, and we're on a road that is a straight line that goes to a second city that's 75 miles east. So we are 75 miles east like that. So we are driving in between these. We can actually construct this line. So we know if we had some y equals mx plus b, the slope would be the change in y. So that'd be like 0 minus 66, so negative 66 there. And then 75 minus 0 over 75. Plus b, which is our y-intercept, which is just 66. So we're on this green road right through here. And when we are within this red circle, that's when we are able to listen to that radio station. And we want to know, well, how many miles of this trip from here to here, from city A to city B, I'm going to write cities here. We want to know how many miles is this stretch of it right through here. How many miles, right, are we going to be able to pick up that signal? So from these two. So what's important here is if you're using Desmos, it's a fairly straightforward question. You want to figure out the distance of this segment right here between the 2 points I've selected. And the distance formula is going to be this. So it's going to be the square root of x sub 2 minus x sub 1 squared plus, do it again for y, so y sub 2 minus y sub 1 squared. So whichever values you pick for x2 is up to you. I'm going to go ahead and pick this second point here. So 48.852. That's what I'm going to have here, 48.852. And then for x1, or for y2, that means it's going to be 23.01. So that's how I'm representing this part. Right? That's that coordinate that along that road. That's where we lose the radio signal. Our entry point is this one here. So my x1 for that is going to be this 16.612. And my y coordinate for that is going to be this 51.381. So I'm going to have to stretch this out a little bit here. And again, it's 51.381. And the distance is going to pop out of this thing. Now, of course, I would never do something like this by hand, right? The potential for human error is too big with it. Okay, but this is what I want. I want to know that distance right there, which in Desmos, I could take it, copy and paste it right right over, and then off we go. In almost every iteration, this is going to work. Where it's going to go wrong is, of course, Desmos is rounding these things off. So it is rounding this off to the thousand, so 3 decimal places afterwards. So of course, where that where that becomes large enough would be, I would argue, in several hundred iterations of it. So I'd bring up another version of it because that's what's happening. The longer version is a little bit more cumbersome, which I can do in a separate video. For those that are interested, please let me know, and I'm more than happy to make that. All right, have a good day.